Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today is a fun session. I want to go over what we call the Chinese Remainder Theorem, and I'm going to introduce it probably slightly differently from, if you read it in a book or something. And the idea here is we can give you, it's like a riddle. Let me try to come up with something. So let's say if I have a number, and if I divide it by 5, I get a remainder of 2. So I write it as 2 mod 5. And if we divide it, let's pick another prime number, 7, for example. I say if I divide it by 7, let's say I get 3. And then I can pick a 3 or a 2 or 11. Maybe if I divide it by 11, I get, let's say, 2. What is the smallest number that satisfies that? Of course, I'm not going to say try, like trial and error. Doesn't make sense. But what I'm going to do is, once I find the answer, I can add or subtract from it a multiple of 5 times 7 is 35 times 11. I can add or subtract 385, and the answer would be correct. So what do I do? I'm going to write the 2, the 3, I'm sorry, the 5. Why did I say 2? I was writing the remainder. 5, 7, and 11. And since all 3 of them are primes, they're prime with respect to each other. In fact, they are primes, but I may have a number like a 4 that is not prime, but it would be respectively prime with 5, 7, and 11, or what have you. So if I have that, I'm going to say the following. What multiple of 7 times 11 when divided by 5 would give you a remainder of 2? And you say, why did you hide the 5? I say, because if I keep adding 5s, it won't change anything, right? If I say 2 divided by 5 is a remainder of 2, so when I add 2 to 5, I get 7. Yes, the 7 has a remainder of 2. I add another 5. 12 has a remainder of 2. So adding 5s doesn't add or change anything. So all what I'm going to do, 7 times 11 is 77. And 77, when you divide it by 5, you get a remainder of 2, of course, right? Because anything that ends with 0 or 5 is divisible by 5. 75 is divisible by 5, which leaves a remainder of 2. So I'm going to write 77. Same thing for the 7. I'm going to hide the 7 and say 5 times 11 is 55. When I divide 55 by 6, I know that, I'm sorry, by 7. Why did I say by 6? 77 by 7, I get 7. That's 49, and I get the remainder of 6, not 3. But notice, when I took the 55, I get a remainder of 6. So if I take another 55, notice 6 is 1 less than 7. So if I add another 55, it drops by 1 again. If I add another 55, the remainder would be 4. And if I add another 55, the remainder would be 3 like I want. So I'm going to say plus 220. Even divide 220, it says remainder of 3. So if I subtract 3, I get 217, and 217 is divisible by 7. So that would be a remainder of 3, as we said. Finally, to do the 11, I'm going to say 5 times 7 is 35. 35 divided by 11, well, 33 is divisible by 11. So that leaves a remainder of 2. So I simply write 35. I don't need to multiply it by anything. And when you add those, you get 12, you carry over 1, 3, you carry over 1, 332. Divide 332 by 5, a remainder of 2, because 330 is divisible by 5. By 7, if you divide 33 by 7, you get 4. 4 times 7 is 28, so that's 52. 52 divided by 7 is 7. 7 times 7 is 49. Out of 52, a remainder of 3. And sure enough, if you divide 332 by 11, I know that 330 is divisible by 11, right? 33 gives you 3 and 0. So that means a remainder of 2. So the answer is 332. If that answer was less than 385, I'm sorry, more than 385, I would subtract 385 to get the smallest possible number that is divisible by, when you divide by 5, you get a remainder of 2. By 7, you get 3. And by 11, you get 2. Okay? So that's how we are going to do it. I'm going to show you another one, and then or before that, I'm going to give you a problem and let you think about it, and maybe I will post the solution later. Or if you find the answer, just write it down in a comment, and I will tell you what. If it's right, I will leave it. So I leave it for a few days, and then if nobody gets the correct answer, which I believe you would, I will write the answer for you. The problem is called the calculation or the computation of Burma. Burma is a city or a village north of Cairo in Egypt. So most Egyptian, I don't know the new generation. I haven't been there for a long time or to discuss it. But for old people like me, they would know the answer even if they don't know how to solve it, because they heard, the riddle several times, and they know the answer already. So I'm not going to tell you the answer, but I will tell you the problem. The problem is about a lady who was selling eggs, and on her way to the market, she slipped and dropped the basket, and all her eggs, was broken, and she was crying. And somebody asked her, "Lady, why are you crying?" So she told him the story, and he asked her, "How many eggs did you lose to cry all that?" She said, "I don't know. I don't know how to count, but I tried to put them by twos, count them by twos. One remained. Then I repeated and count them by threes. I got a remainder of 1. I was about to give up. I tried a remainder of 4. Count by 4. I got a remainder of 1. I counted by fives. I got a remainder of 1. Oh my God, it's so boring, right? Divided by 6, I got a remainder of 1. And finally, when I divided by 7, I didn't get any remainder. So what is the least number of eggs did she have? I will, if nobody gets it, maybe I'll make a short video and show you how to count them, because I'm not going to go over a problem that has a remainder of 0. That is a little tricky. But I did another problem, and not like, I called it Muhammad, calculation of Muhammad, because I came up with it. I mean, it's not a big deal, but, and I said, no, I'm going to make it change that. I'm going to say, what if she divided by 2? So when you divide by 2, you got a remainder of 1. They said, this guy is crazy. That's exactly what the lady said. So what are you trying to do? So, bear with me. Okay. When I divided by 3, I get a remainder of 2. When I divide by 4, I get a remainder of 3. When I divide by 5, I get a remainder of 4. When I divide by 6, I get a remainder of 5. And if I divide by 7, I get a remainder of 6. What is that number? Okay. Now, notice that I'm not going to pick the 2. I'm going to pick the 4. Why the 4? Because if a number, if I divide a number by 4 and get a remainder of 3, then definitely with 2 would get a remainder of 1. But if I use the 2, I may get a remainder of 1 also for the 4 instead of 3. So I pick the 4 because this has a 2, this has a 2, but this has two 2s, so you take the maximum, right? I have a 3 because I cannot pick the 6 because the 6 and 4 are not relatively prime. Then I pick the 5 and the 7. 3 times 4 is 12, times 5 is 60, times 7 is 420. So if the number I get is more than 420, like here, if it were more than 385, I would have subtracted 385. So I can say any number plus or minus 420n, and n is an integer. Okay, so let me write them down like we did before. 3, 4, 5, 7. To see if a number is divisible by 3, 4 times 7 is 20, plus, times 7 is 140. 1 plus 4 is 5. That's a remainder of 2, so 140 is okay. I'm going to write 140. To see the 4, 3 times 5 is 15, times 7 is 105. 100 is divisible by 4, and 5 will give me a remainder of 1 when I divide it by 4. So I need to multiply that by 3 to give me a remainder of 3, right? If every 105 gives me a remainder of 1, I need to multiply it by 3 to get a remainder of 3. Then I go to the 5. 12 times 7 is 84. 84 divided by 5 has a remainder of 4 because 80, any number that ends with 0 or 5, is divisible by 5. So 80 is divisible by 5, so 84 will have a remainder of 4. Great. And finally, by 7, I get 60. 60, when I divide it by 7, I get a remainder of 4. I don't want 4, I want 6. How do I do that? Let's do it. If I add another 60, notice the 4, meaning I dropped 3. I drop 3 and I will have a remainder of 1. Or somebody can say, oh, 4 plus 4 is 8, meaning a remainder of 1 with 7. You can subtract or add, it doesn't matter. If you add 3 60s, then you add another 4, so the 1 becomes 5. Still not 6. If I add another 60, I can either add 4 or subtract 3. It's up to you. Add 4 is 9. 9 over 7 is a remainder of 2. And finally, if I add another 60, you add 4 and you get a remainder of 6. So 300. Add them up, you get 9. 5 and 8, 13. You carry over 1. 839. Okay. So 839 is more than 420. So I'm going to subtract 420 and get 419. Let's see. Divide 419 is odd, so when you divide by 2, you get a remainder of 1. The 9 is divisible by 3. 4 plus 1 is 5, so when you divide that by 3, you get a remainder of 2. 416 is divisible by 4. This is 3 more, so you get a remainder of 3. 415 is divisible by 5, so a remainder of 4. 420 is divisible by 6. This is 1 less, so you get a remainder of 5. Again, 420 is divisible by 7, so 1 less would give you a remainder of 6, and that is the answer. Now, I think you may be able to solve the permutation or calculation of Burma. I'm gonna leave it for a couple of days. I will check every day to see if you have the correct answer. If not, then maybe I will make a short video and show you the answer to this one. Otherwise, I wish you all the best and hope to see you soon. Bye.